So today's topic is Revit integration with Civil 3D. So this is an interesting topic that probably goes back to several years when Autodesk had introduced several different applications and add-ins, extensions that work with between Revit and Civil 3D. I think we're not there yet as far as complete integration. I don't want to claim that today, but I want to say that we have made a huge quantum leap into the integration, and the digital information-rich models are able to be exchanged back and forth between not only Revit and Civil 3D but also other applications. So exporting Revit Families utilizing the AutoCAD Civil 3D extension is designed to transfer any solid Revit family into on an AutoCAD Civil 3D format. So all Revit refinements and details are exported as a solid geometry. So this has been enhanced quite a bit in the current version of 2017. The integration with AutoCAD Civil 3D extension is designed to transfer the data related to topography, roads, and bridges elements between Revit and AutoCAD Civil 3D. So this webinar sheds the light on the round-trip workflows between architects, structural engineers on one hand and civil engineers on the other hand. And this includes also the interoperability with Format 360 Pro and Infraworks 360. So those tools are used mostly in the conceptual design phase of the project, and then Revit and Civil 3D are used more into the design development construction documents phase of the project. So let's get started. As you know, the AEC delivery process for projects is a big circle where you can start anywhere on the circle. Typically, most people start during the conceptual design phase over here, and wraps around and ends at facility management and operations and maintenance. But it goes through different steps. I'm trying to emphasize this process because you could be starting within some existing conditions. You could be starting completely with a blank slate, but somewhere it involves somewhere along the process. Your design workflow involves some type of conceptual design tool, some type of engineering tool and master planning tool, and then of course architectural and structural. So as a reminder, the Autodesk Architecture, Engineering, and Construction Collection, the AEC Collection, includes AutoCAD Civil 3D, Revit, Vehicle Tracking, Format 360 Pro, Infraworks 360, Inside 360, and of course your A360 cloud storage. These are very important tools in your arsenal to design projects and make the information flow between those applications, and share your files on the cloud. So let's get started. I'd like to get started with some conceptual sketching. So typically, when it comes to putting the building on the site, you're dealing with some geolocated address. I'm going to borrow this from another webinar, but they basically showing how the site can be taken with the building model through different phases of the project, from conceptual to Google Maps, bringing in, typing in the address of the site, and start sketching the building footprint, and then eventually we're going to take this to Revit, to Infraworks, and Civil 3D, and back into Revit. So it's a full circle that I'm trying to propose here, and I would say that every project should start in a similar way, where you're not drawing in vacuum. You're using something that is based on some geolocated information. Here we have a site that's located in Miami, Florida. We have a highway nearby. We have a high school on the right-hand side, and we have some track and field features on the left. By simply sketching the footprint of the building, we should be able to fine-tune this to a level just enough so we'll be able to make sure it fits within its context. So this is all about this webinar is about the integration between the site and the building design using different applications. So by developing, I'm fast forwarding the video right now, and by developing this to the next level, we should be able to figure out the building footprint, the height of the building, any features that affect the orientation and the lighting of the building, and the heat gain, heat loss. And here we're using, we can save it into a specific file format, such as FBX and OBJ, or we can even send it to AutoCAD A360 drive or team for file storage and sharing. Other people are able to join me while I'm doing this to work with me on a collaborative workflow. And as you can see, the workflow is very intuitive and very fast. So I don't have to worry about, what type of canopy is this, what parameters is there. It's just a placeholder for what comes next. So the next thing I'm going to show you is how to pull that same model from the cloud storage and then simply start a sharing session. So what we're doing right now is inviting another colleague for real-time collaboration. I think this is very important. This is one of the latest additions to Autodesk workflows that I really believe in is going to change the way we do business as architects, engineers, civil engineers, construction managers, and master planners. So I'm sending here a link using just a simple email, and one of my colleagues is going to join this meeting. His name is Mark Bertucci. You're going to see his picture now. He's now the one who is controlling the model. He's spinning this around, and his image just appeared on the bottom right of the screen. He's going to add some more information to this model, such as levels, and basically get a ballpark figure of what the square footage is for this project. Once we feel the project is good to go as far as it fits, it fits with its in its context, the north orientation, north, south, east, west orientations are appropriate. We can just do a quick solar study to see how will these canopies respond and what kind of effect that will have on the project. We can also run a building life cycle analysis, which will allow us to not only study the solar, but also study the either the monthly peak or the year cumulative heat gain, heat loss of the building. That's very important to make sure we set the proper orientation and make sure we have the proper shading devices. So here we have the yellow areas are receiving the maximum sun in BTUs. We have the magenta areas are the cool areas of the building, and the orange are facing west, which means that they receive a substantial amount of sun. That gives the designer a very basic idea on where to put those shading devices and louvers of the building, whether it should be horizontal or vertical, and basically make some decisions regarding materials, material selections, glazing, double pane, single pane, triple pane, low E glass, that kind of stuff. So next we will bring in the model using the import format 360 to Revit tool converter. We'll bring that model into Revit, and then we will move on to the next level, which is coordination with Infraworks and Civil 3D. So if you haven't used Infraworks 360, I suggest you take a look at it. It should be part of your either the suite or the AEC Collection. When you use Infraworks 360, you're basically looking for a specific address on the map, such as this one in Miami, Florida, 1200 Northwest 6th Avenue, Miami, Florida, and you can basically let Infraworks 360 pull the GIS information, geographic information system data from different state records and create the model for you. Once the model is created, it will send you an email saying, yes, the model is ready, go grab it. So you go open that up. This is live on the cloud, by the way. So we're what you're getting here is basically a bunch of infrastructures, bridges, and roadways that are adjacent to the site. As you can imagine, this is a very, very busy intersection. So what we do on the site is going to be affected by this circulation. So we will need to look at traffic simulation. We need to look at other types of simulation here. So what happened to the building? The building, we're going to bring it back now, import that into Infraworks 360, and eventually we'll end up in Civil 3D. So if you're waiting for the Civil 3D part, it's coming. So we'll bring in the building natively as a Revit file into Infraworks 360, add a bunch of trees, water areas, and then we'll probably need to adjust the roadways around the building as well. Here we're doing a quick soil study to make sure that we have what we think we have in terms of orientation. And you can see the shadows of the highways being casted during the sunset hours on the building itself. This is during the morning hours. Okay, so I'm actually going to fast forward this because I don't want to spend too much time here. So Infraworks is able to do different types of analysis based on any criteria that you give it. So this criteria in particular is elevation above sea level. So any orange areas are pretty low, and any blue areas or green areas are high. So you see the building is sitting near the blue-green areas. So we should be okay as far as flood prone areas. You can measure in 3D. You can measure length, width, and height of the building and verify that it's appropriate. Make sure you set your units. This is one of the things that can bite you at the end. So you just want to use the software without checking for units, whether they are in meters or feet in inches. You can add some simple elements such as trees and bollards around the building. And next is, what do we do next? We want to take the site back to the BIM authoring tool, or we want to take it to Civil 3D for engineering, further engineering type work. So in this case, we're bringing the model into Format 360 Pro for then later on we will bring it into Revit so we can see it inside the BIM authoring tool. Again, imagine the amount of work that has been saved just by doing this. Okay, so next we will look at how did we modify some of the design roads inside of Infraworks 360. So what I did was I basically called upon one of my colleagues, Ken Driscoll, who's a civil expert, to adjust some of the roadways here around the building in Infraworks. And with just simple controls, push and pull, he's able to not only adjust it to meet DOT standards, but also eventually you'll see he's working on he can adjust the road profile to make sure that it meets certain requirements. He took out some of the roadways here in the parking lot, and he's adding another road to wrap around the building with the proper radius. So I'm just simply going to just fast forward this a little bit. Adding trees is very simple because you're adding them as a whole bunch of trees where you can adjust the number of trees. You can delete buildings on the site and add some water areas. Again, this is all conceptual, quick and easy at the beginning of the project. We're not making accurate decisions here. We're just making sure that we have met the project requirements. And this is where Ken is able to join me in a real-time collaborative session in Infraworks and is able to modify the road profile in real time. I think this is fascinating because this ability was not available some time ago. So this is a lot of this technology you're seeing here is pretty much cutting edge and very conducive to a collaborative process. Okay, let's go to the next where we're going to work with taking the Infraworks 360 model into Civil 3D.
Hey, oops, what? Do we have a staff login? Because I see that you have a login for that. I mean, I'm into the webinar, but I can't talk if he needs me to talk. Okay. Yeah. Okay. Let me see here. Okay, that's fine. I'll see what I can do. Cool. All right. No problem. Bye.
We can import that IMX file. Okay, we'll verify the coordinate systems and then refine the selection set. So we're going to bring in the existing ground surface and the proposed ground surface into Civil 3D, along with we're not going to actually bring in the alignments for the roads. Okay, so the model opens up in Civil 3D. We have two surfaces. And then we'll merge the two surfaces together so we can take them into Revit. The third surface will be created as a final surface. We'll give it a name, final.
Oh, I can be heard. Thanks, Sean.
All right, so now the two surfaces are together and we can take it now into Revit. So let's take a look at how this will come into Revit. So using the Revit Civil 3D integration, add extension for Revit, we'll bring in this surface into Revit. We'll basically, we have the choice between assigning a material. In this case, I'm going to do it as earth. And then when it comes in, as you can see. And once it comes in, we'll be able to edit the points of the surface. This is a topo surface that's valid to be edited inside of Revit. Okay, so in the interest of time, I'm just going to fast forward here so we can see how this thing would look inside of Revit. Basically, what you have here is the building sitting on the site with the topo information and the low areas, the water areas, the infrastructure, even the trees come in. And what we have here is a situation where we're ramping up creating these perspective views in Revit so we can get ready for a presentation. So stick around for more stuff. I'm going to show you some other techniques I've used for integration of the site and the building. Okay, so in Revit, we've just created this monochrome type presentation with elevations, and you can see the infrastructure in the background. We're using the latest feature in Revit, which is depth queuing, which allows you to kind of fade what's in the background. And with very simple techniques of massing in Revit, you're able to apply curtain system by face, roof by face, and get some really nice results. And this is just all schematic stuff. All right, so what else can we do with this tool? We can integrate a Revit model and send that entire model into Civil 3D. So this happens to be a hospital, a structural part of the hospital, and we're using the export Revit elements into AutoCAD Civil 3D. This tool, in my opinion, beats the ADSK file format that was used in the past, and allows the both architects, structural engineers, and civil engineers to be able to very quickly send the model to the civil engineer, and then make sure that everybody is coordinated as far as the origin point of the file. I'd rather not use shared coordinates when possible. There's no reason really to not be able to set the origin of the file at the beginning of the project and avoid the shared coordinates headache. So if you haven't done this before, the origin point in Revit can be relocated to any location on the site, and I would recommend putting this on the somewhere on the property line of the site. So there's very few areas of the project that doesn't change during the course of the project. One of them is the property line. So if you had a property line for the site, this is where I would recommend placing that model origin. You could just coordinate that with the civil engineer. Usually the civil engineer will have some type of site coordinates that they go by, and it could be very, very far from the project. You want to avoid that because Revit will has a limit on the extent of the project. If it goes beyond 20 miles, then it will give you an error message, or maybe your project components will be inaccurate. So avoid creating a project in Revit that's greater than 20 miles as a cube. So here we have even a Revit architecture file that's been transferred into Civil 3D. So not only the structural part is transferred, but also all your walls, doors, windows, even furniture, everything gets transferred, and it's created as a solid, which is fine. It's just a great placeholder for it, and which allows the civil engineer to be able to work with it and bring the utilities to the certain points around the the site and work with different sidewalks and curbs and gutters and canopies and that kind of stuff. All right, so more about that. So I have here a busy intersection that I got from my colleague Ken Driscoll, and I'm going to just simply bring in as a link into Revit. So as you can see, the message on the screen is that you got an issue. You got the extent of the drawing are more than 20 miles. So you may have some issues. So you want to avoid that. This is a traditional way of working between Civil 3D and Revit. You link in the AutoCAD drawing, you select which layers you want to use for your topo information, and then Revit will generate the topo for you. Then you can set your section box, especially if the extent of the drawing is huge. Get your section box turned on, start defining the extents of the model, and you can do certain things here without spending too much time. Basically, creating a user experience, navigation, and understanding how this thing works. So here we have the AutoCAD model from Civil 3D superimposed on top of the Revit surface. And we're just simply using the navigation tools of Revit to look around and to understand and do like a quick walkthrough under this bridge. So it's great for initial studying of the project parameters. Let's take a look at parking layout and vehicle tracking. So all of this have to do with going back and forth between the civil engineer and the architect drawings, and make sure that the project is coordinated. Here we have an emergency vehicle that is using the vehicle tracking app that runs on top of Civil 3D and animating the vehicle tracking of an emergency vehicle like a fire truck. So this is so easy to use that even I can use it without any knowledge of Civil 3D. Just being able to use that VCR dashboard in 2D or 3D and then simply run the animation of the fire truck around the building. Very important to make sure that the design is valid and the emergency truck is not hitting, for example, the canopy of the building or interfering with any other exit requirements. So here we're showing the focal length of the camera over the fire truck, how you can just simply adjust what type of view you want from that emergency vehicle. Again, I'm pretty sure you guys can create better animations than this, but this is kind of gives you an idea of how to start the process, create the animation, and simply adjust the camera and the target and simply present that maybe in a public hearing to make sure that everybody is cool with the design itself. Okay, another workflow, importing the site topo from Civil 3D into Revit. So this is a pretty large site. We're using the same building for the hospital to import that into Revit. You see the user interface here. We're creating a terrain. That same topo on the right-hand side is going to show up on the left-hand side now in Revit. And when it comes in, you can't see it sometimes because of the elevation of the site. So hopefully you had this coordinated before you move on too fast. And you can see that it's set at a certain elevation above sea level. So you see that paper-thin topo is showing up above the building now. So what you may want to do is adjust. In most cases, you want to bring in the building up to the level of the topo, not the other way around, because now you're coordinated with the civil engineer and all other disciplines. Once the elevation is set, then you can set a section box around that topo, and you can even edit it and create any type of modifications, slight modifications to the topo. Let the civil engineer do the major modifications, such as the road design and any water detention areas. But when it comes to the immediate vicinity of the building, you want to be able to work with the building pad and sidewalks, any stairs and ramps, and coordinate connections to the building utilities. So here we're playing architect to make sure that the building pad is set correctly, and we're doing most of the work in a 3D view. It can be done in a side view as well, but showing that this, I'm showing you that this is a pretty easy task. That a lot of people kind of shy away from working with 3D site models, and it's not really a big deal. It can be done. So the building pad command allows you to set a building pad to avoid around the perimeter of the building, to avoid all this dirt to come into your basement areas. And that's how it's done. So let's move on to something else. So if you may have seen this before, this is vehicle tracking and parking layout. I think this is great. Part of okay, so I'm hoping you can hear me now. I'm sorry about that. I got the mute button turned on by mistake. So the next is we want to look at how to use the Infraworks feature to send a bridge from Infraworks 360 into Revit. Okay, so let's run this. So basically, this video shows right-click on a bridge in Infraworks 360 and send it to Revit. This will open the Revit application and shows the bridge inside of Revit. It's not the same workflow that I showed you earlier, where you can bring in the entire model, but it's definitely a very good working solution for structural engineers who are working on bridge design, because it brings the piers, the foundations, the beams, the railings, all as valid Revit families. Okay, I'm going to show you a couple more workflows, and then we'll take your questions. So give me a second here. So this workflow also shows integration of AutoCAD Civil 3D and Revit. We're bringing in the whole intersection. but showing you the different road and terrain definitions, horizontal alignment, cross sections, and topography. We're setting the topo to Earth, and then we're going to bring this into Revit. Just different. These are just from different attempts at doing the same thing. This shows this exchange in Infraworks 360 before it was brought into Revit. And you can see also a picture of my colleague Ken Driscoll here. We're helping me with it. So we're just showing that there are different workflows for this, and showing that it can be done in different ways depending on what type of discipline you want to use this for. So for the structural engineer, this would work very well. For the architect, you may want the entire site and the building geolocated on the site itself. Okay, so we're getting to the end of this. I'm going to turn it over to Casey in a couple of minutes from now. So basically, the applications that I've used in this webinar comprise of Autodesk Infraworks 360 Pro, Revit 2017, Infraworks 360, AutoCAD Civil 3D 2017, Autodesk Vehicle Tracking. And I just want to mention something that that there is another tool that you may want to take a look at, which is the Site Designer V2 update for Site Designer that can bring in land XML files into Revit and export land XML. My experience with it has been a little bit cumbersome. It's not as fluid, as easy to use as the other tools, and so I did not actually show this today in our workflow because I prefer the other workflow with the extension of that shows the integration between Revit and Civil 3D. With that, I'd like to turn it over to Casey for any questions. Thank you. Casey, do you have any questions?
I apologize, I was still muted. Okay, it looks like we only had one question, but Jason did answer it, but I will go ahead and read it out loud in case anyone else isn't able to see it. If you grade a surface in Civil 3D, an example break lines, and then import the surface into Revit, will the surface created in Revit include the grading created in Civil 3D? And Jason's answer was the surface created in Revit is usually only contour data. The break lines define the surface, so you will only see the defined surface. Does anyone else have any other questions? Let me see if I have any other ones coming in. Okay, what application or add-in is required for Civil 3D for the vehicle tracker and parking layout tools?
I think we've answered this question. Let me see. Here we go. I think I tried to summarize the applications that we have used in this webinar. So basically, it would be the Autodesk vehicle tracking. This is the application to use for animation and for parking layout.